A few days ago, OpenAI released their official prompt engineering guide. And in this guide, they share 6 strategies for getting better results with GPT-4 and their other models. So in this video, we're going to walk through this guide together. We're going to look at their examples, and hopefully we'll all learn how to prompt the GPTs and get better outputs, get better responses. All right, let's check out this guide. Hopefully after this, we'll have no more guessing. A lot of people are experimenting with different kinds of prompts, different ways to write the prompts, different symbols to use to signify importance for certain lines. This is from OpenAI. This is written by their staff. So we shouldn't need the forums. We shouldn't need the subreddits. This should tell us everything we need to know. And I skimmed through it earlier, and I did notice a few things that we've been doing wrong. So we're going to fix that in this video. It starts off, this guide shares strategies and tactics for getting better results from large language models, sometimes referred to as GPT models like GPT-4. The methods described here can sometimes be deployed in combination for greater effect, and we encourage experimentation to find the methods that work best for you. Some of the examples demonstrated here currently work only for our most capable model, GPT-4. Hopefully in the future, GPT-4 Turbo is cheap enough that we won't even need to use GPT 3.5. But right now, there are use cases. Anyways, in general, if you find that a model fails at a task and a more capable model is available, it's often worth trying again with the more capable model. Makes perfect sense. And it says you can explore example prompts which showcase what our models are capable of. Quickly looking at the prompt examples, this seems to be the same thing that's been released for like a year now. And when I went through this, I didn't find anything mind-blowing, so I'm going to ignore it for this video. But if you're interested, you can check it out at platform.openai.com/examples. Okay, the 6 strategies for getting better results. Number 1, they want us to write clear instructions. It says these models can't read your mind. If outputs are too long, ask for brief replies. If outputs are too simple, ask for expert level writing. If you dislike the format, demonstrate the format you'd like to see. The less the model has to guess at what you want, the more likely you'll get it. Before looking at the examples, what I'm getting from this is start with your prompt of what you want, look at what the model generates, and then adjust from there. I've noticed that every one of my outputs, even if I want something very short, they're all super long. The model explains why it's doing it. It educates on things that I already know. So in that case, I'd have to change the prompt to tell the model to make shorter responses. I don't experience the too simple outputs that much. And then if you don't like the format of the output, provide examples. And we've been doing that lately with all of our custom instructions. The first tactic is include details in your query to get more relevant answers. In order to get highly relevant responses, make sure that the requests provide any important details or context. Otherwise, you are leaving it up to the model to guess what you mean. The best example here is just asking who's president. How can the model know which country or territory you're talking about? But if you ask it who is the president of Mexico in 2021, you're going to get a direct response. They also give an example of summarize the meeting notes is not a good prompt, but summarize the meeting notes in a single paragraph, then write a markdown list of the speakers and each of their key points. Finally, list the next steps or action items suggested by the speakers, if any. That prompt is much better, and I can even visualize what that output is going to look like. Asking the model to adopt a persona. The system message can be used to specify the persona used by the model in its replies. So the system message is a feature of the playground, but we can do system messages in ChatGPT as well. Just use custom instructions. So when the guide refers to the system message in the future, it's probably going to talk about that a lot. It's talking about the playground and then this input box right here. In ChatGPT, the system message would be down here over your profile, hit custom instructions. I would use these 2 input boxes. And in custom GPTs, the system message would likely be put in the instructions input. So their example is, when I ask for help to write something, you will reply with a document that contains at least one joke or playful comment in every paragraph. It's setting the stage for the entire conversation. Then the user writes, write a thank you note to my steel bolt vendor for getting the delivery in on time and in short notice. This made it possible for us to deliver an important order. So that output should be a thank you note with some jokes sprinkled throughout. Use delimiters to clearly indicate distinct parts of the input. Delimiters like triple quotation marks, XML tags, section titles, etc. can help demarcate sections of text to be treated differently. So this one's very interesting to me because if you've been following my recent videos, we've been using 2 forward slashes to indicate important parts of the text and different sections of the prompt. But here it's using 3 quotation marks, and it's also telling the model to summarize the text delimited by triple quotes. It's showing what to look out for. When we got the ChatGPT system prompt, especially under the DALL-E 3 section, its prompt was using the 2 forward slashes. In their prompt guide, they're telling us to use 3 quotation marks. So I think we should experiment with both to see what gives us better outputs. This example shows XML tags, and this is interesting because I've been using stars. A lot of my prompts have looked like this. Write a summary about this article, then I use 3 stars, I paste in what I want a summary of, and then end with 3 stars. They're now telling us to use XML tags. So this would be an XML tag, article, and then end the article, and then paste that article in between. And in this last example, they write prompts like we normally write them. Abstract, colon, and then insert the abstract here. And then title, colon, insert the title here. So that does seem to be okay. They add a little note that for straightforward tasks such as these, using delimiters might not make a difference in the output quality. However, the more complex a task is, the more important it is to disambiguate task details. Don't make the model work to understand exactly what you are asking them. So in that article summary example, it's probably okay to just write article, colon, paste the article here. But in a multiple step, complex task, we should probably use delimiters. Tactics: specify the steps required to complete a task. Some tasks are best specified as sequence of steps. Writing the steps out explicitly can make it easier for the model to follow them. Awesome, we have been doing this. In all of my custom GPTs, I use the step 1, step 2, step 3 approach. And GPT Prompt Fixer, this custom GPT actually turns what you want to accomplish into a series of steps. For example, this is the custom instruction for that GPT Prompt Fixer. We have a task and then step 1, step 2, step 3. Now I'd probably change this to the 3 quotation marks. But it's cool to see confirmation from OpenAI that we're writing prompts the right way. The next tactic is provide examples. They say that providing general instructions that apply to all examples is generally more efficient than demonstrating all permutations of a task by an example. So basically, general examples work better than specific use cases. And this is an interesting demonstration. The system message is answer in a consistent style. The user says, teach me about patience. The assistant answers that prompt. And then the user now says, teach me about the ocean. And in theory, it should respond similarly to this response here, because it's looking at the system message of answer in a consistent style. So for one conversation, if this conversation were to continue, it should keep spitting out results that replicate the first one. Now, different conversations will have different first responses, but we might be able to use this in some of our custom GPTs. And I wonder if this works for DALL-E 3 as well. And the last tactic is specify the desired length of the output. The big point from this paragraph is instructing the model to generate a specific number of words does not work with high precision. The model can more reliably generate outputs with a specific number of paragraphs or bullet points. So we need to stop saying in our prompt, write an article that is 1,000 words. And instead we need to say, write an article that has 3 or 4 paragraphs. Or if we were doing something with bullet points, we'd say something like, Write this summary with 5 bullet points. The second strategy for getting better results with GPT-4 is to provide reference text. Large language models can confidently invent fake answers, especially when asked about esoteric topics or for citations and URLs. In the same way that a sheet of notes can help a student do better on a test, providing reference text to these models can help in answering with fewer fabrications. Tactic 1, instruct the model to answer using a reference text. If we can provide a model with trusted information that is relevant to the current query, then we can instruct the model to use the provided information to compose its answer. And the example here is the system message says, use the provided articles delimited by triple quotes to answer questions. If the answer cannot be found in the articles, write, I could not find an answer. And the user is actually providing the examples first before their question prompt. I always thought it was the other way around. Prompt first, order of importance, examples last. This is interesting. Now this is super frustrating with custom GPTs, and our reference text is usually uploaded to the knowledge base. And even if you specifically ask the custom GPT to look into its knowledge base for the answer or for references, it still seems to only work at like a 50% hit rate. So they need to work on that. This is what they're telling us to do. We're trying to do it with custom GPTs and it's not working out. The second tactic is to instruct the model to answer with citations from a reference text. And this is the same example as the one before, but it's almost asking the model to prove that it looked through your reference text. And it's asking the model to prove it by citing where they got it. That's a pretty cool idea. You're treating the model like a student where they have to provide a proof of work. Strategy number 3, split complex tasks into simpler subtasks. Just as it's good practice in software engineering to decompose a complex system into a set of modular components, the same is true of tasks submitted to a language model. Complex tasks tend to have higher error rates than simpler tasks. I found that to be the case too, which is why I've been splitting up my custom GPTs to do one little thing at a time. Instead of one giant custom GPT that can do it all, I have a workflow of smaller GPTs. I like to call them AI agents. Furthermore, complex tasks can often be redefined as a workflow of simpler tasks in which the outputs of earlier tasks are used to construct the inputs to later tasks. This is much easier to build with the API than it is in ChatGPT because you can control the workflow. Tactic number 1, use intent classification to identify the most relevant instructions for a user query. So in this example, they break down one large workflow into multiple steps so that you don't have to keep passing on the initial system message in all of your future prompts. Therefore, it simplifies your inputs and it also saves on your cost if you're using the API. This example here is giving a customer service bot a bunch of primary categories and secondary categories, and then asking to put the customer inquiry into a primary category and then a secondary category. So the output is taken and saved, and then we use in the real prompt down at the bottom here. This is almost like setting a state for the rest of the conversation, which is awesome because it puts guardrails around the user experience that would be hard to achieve with a less structured approach. And this is a perfect use case for customer service bots because you don't want it going off the rails, answering things that don't make sense. You want to keep it within a primary and secondary category and have an output that is relevant. The next tactic, for dialogue applications that require very long conversations, summarize or filter previous dialogue. Since models have a fixed context length, dialogue between a user and an assistant, in which the entire conversation is included in the context window, cannot continue indefinitely. Makes perfect sense. You can't have a conversation go on forever and then ask the model to remember what was said at the start. Their suggested workaround here is that once the inputs and outputs reach a certain size, and this is going to depend on which model you use, but let's say it reaches 25,000 tokens, you can tell the model to summarize what was said in the previous 25,000 tokens, and then use that summary for your next piece of conversation for the next 25,000 tokens. And then if you use the API, you can actually save this summary in a database and keep referring back to it at later points. The next tactic is summarize long documents piecewise and construct a full summary recursively. Again, since models have a fixed context length, they cannot be used to summarize a text longer than the context length minus the length of the generated summary in a single query. Yep, that's pretty understandable. And they give the example here of a really long book. You can't just paste the entire book into the input and say summarize this. The context length is too long. It's not going to get a good response. But if we break that book into something like, let's say, chapters, we can summarize each chapter and at the end put all the summaries of all the chapters together into one big summary for the user. Strategy number 4, give the model time to think. What is this one? If asked to multiply 17 by 28, you might not know it instantly, but can still work it out with time. Similarly, models make more reasoning errors when trying to answer right away, rather than taking time to work out an answer. Asking for chain of thought before an answer can help the model reason its way towards correct answers more reliably. Wow, that's so interesting. Let's take a look at these tactics. Instruct the model to work out its own solution before rushing to a conclusion. Sometimes we get better results when we explicitly instruct the model to reason from first principles before coming to a conclusion. Suppose, for example, we want a model to evaluate a student's solution to a math problem. The most obvious way to approach this is to simply ask the model if the student's solution is correct or not. So they give an example here that the system message is determine if the student's solution is correct or not. There's a problem statement, which is an underlying math problem, and then the answer to this prompt is that the student's solution is correct. But the student's solution is actually not correct. We can get the model to successfully notice this by prompting the model to generate its own solution first. So we get the model to do the math itself, then look at the math of the student, then it can easily compare its response to the student's response and say that the student's response is incorrect. Tactic number 2. Use inner monologue or a sequence of queries to hide the model's reasoning process. So it looks like this tactic can only be used with the API and not ChatGPT, because you're basically telling the model that its outputs, or the ones that you want hidden from the user, should be within the triple quotation marks. Again, we're seeing the triple quotation marks. So I want you guys to start using these in your prompts. So all of these steps, except step 4, is hiding the model's reasoning process. Because after it generates the answer, we can use code to remove all the text within these delimiters. But you can't really do that with ChatGPT. Everything's going to be visible to the end user. The next tactic in the strategy, ask the model if it missed anything on previous passes. Suppose that we are using a model to list excerpts from a source which are relevant to a particular question. After listing each excerpt, the model needs to determine if it should start writing another or if it should stop. If the source document is large, it is common for a model to stop too early and fail to list all the relevant excerpts. In that case, better performance can often be obtained by prompting the model with follow-up queries to find any excerpts it missed on previous passes. So in the example, we're asking the model, let's say GPT-4, to go through the provided document and pull out the relevant excerpts that pertain to a specific question. The question here is, what significant paradigm shifts have occurred in the history of artificial intelligence? So in your output, you're going to get a bunch of excerpts, but to make sure that the model didn't miss anything, you tell it to go through it again, but don't repeat what you already wrote. So the model is going to pass through the document, look at its last output, and then provide any more relevant text that it needs to. Because it's showing that the models are not perfect. They might miss something on a first pass, just like a human. Like if you were editing a document, you have to go through it multiple times to make sure it's perfect. You're going to miss some errors. Same thing with the model. And yeah, it's going to cost a little bit more money with the API calls, but you're going to get a better response in the end. If you use ChatGPT, it's completely free. Why not make a second or third pass? Strategy number 5, use external tools. Compensate for the weaknesses of the model by feeding it the outputs of other tools. For example, a text retrieval system, sometimes called RAG or Retrieval Augmented Generation, can tell the model about relevant documents. A code execution engine like OpenAI's code interpreter can help the model do math and run code. If a task can be done more reliably or efficiently by a tool rather than a large language model, offload it to get the best of both worlds. So this reminds me of that math problem. If I ask ChatGPT to multiply 57 by 1095, it might give me a wrong answer. But if I say multiply 57 by 1095, but then add use Python code to execute it, it's going to analyze that question and make a code block. And look, view analysis, it did it in Python code and we got the right result. Tactic 1, use embeddings-based search to implement efficient knowledge retrieval. Now they give the example of embedding information of up-to-date sources to get a better output. I know this is not needed in ChatGPT because we have Bing browse the web. If the user asks about a recent movie, it would just search the web to get that information. But with API calls, you're going to have to embed some of this stuff. Tactic 2, use code execution to perform more accurate calculations or call external APIs. And I just showed you that exact example. We asked ChatGPT to do a multiplication, but we wanted it to do it with Python code, and therefore we got a more accurate result. Tactic number 3, give the model access to specific functions. So this is specifically an assistance API feature. We give our assistant functions or actions that will help with its output. And I'll be making a video about the assistance API in the coming weeks. The final strategy, strategy number 6, test changes systematically. Improving performance is easier if you can measure it. In some cases, a modification to a prompt will achieve a better performance on few isolated examples, but lead to worse overall performance on a more representative set of examples. Therefore, to be sure that a change is a net positive to performance, it may be necessary to define a comprehensive test suite, also known as an eval. And let's take a look at this tactic. Evaluate model outputs with reference to gold standard answers. Suppose it is known that the correct answer to a question should make reference to a specific set of known facts. Then we can use a model query to count how many of the required facts are included in the answer. So they're saying in the system prompt that there are 2 facts that each answer should satisfy. This is what they're calling the gold standard answer. So no matter what the input, it needs to be confirmed that it was Neil Armstrong that walked on the moon, and the date that Neil Armstrong walked on the moon was July 21st, 1969. So then we can start testing. If our outputs don't answer or confirm these 2 points, it is a fail. If it does, it is a pass. So as long as we have that base gold answer, we can start fiddling with the prompt and adding stuff in like this part here. Provide a count of how many yes answers there are. Provide this count as bracket count and then insert count here between 2 caret brackets. This one's a little confusing to me, but I get the idea of having a gold standard answer. Like if I was trying to compare the outputs of 2 articles being generated by ChatGPT, there's a lot of personal opinion in there. And if I gave those 2 articles to 50 judges, I might get a 50-50 response. But if I give it a list of important things to include in the output, and one of the outputs doesn't have it, and one of the outputs does, we have a clear winner. That was the official prompt engineering guide recently released by OpenAI. I learned a few things in this video. I hope you did too. My biggest takeaway is the delimiters to clearly indicate distinct parts of the input. We constantly saw through all the examples the use of 3 quotation marks. So I'm going to stop using 2 forward slashes and instead use that. I also like the caret brackets. They use that for XML tags. And this is something I've been doing recently, splitting complex tasks into simpler subset of tasks. And this is perfect for someone like me who's slowly transitioning from ChatGPT to exclusively using the API and in my own apps. I'm now building custom GPTs outside of ChatGPT. I'll have a few for you guys soon, but it's much easier to control when I can break up the workflow myself. The give the model time to think strategy, that one was the coolest to me because I never even thought of this. This is completely new, but it makes perfect sense. And then we had use external tools and then test the changes systematically. All right, thanks for watching, everybody. Peace.